Good morning, students. So let us continue the same concept, which is random variable theoretical aspects I am discussing now. So in the previous video, we could complete up to the results, expectation of a equals to a and so on, variance of ax plus b equals to a square variance of x, and all those results proofs also we have seen, right? Now let us discuss about the bivariate let us discuss about the bivariate probability function. So bivariate probability function. See, you know the meaning of bivariate, right? Where is having two variables, right? Now let capital X and capital Y be two discrete random variables. Two discrete random variables which are defined defined on a sample space of a random experiment let probability of x comma y. So what we have taken, probability of x comma y be a function such that probability of x comma y equals to x takes the real values, the random variable x, and capital Y, random variable y takes the real values, small y. Then this p of x comma y, we call it as a bivariate probability function. So bivariate probability function means let x and y be a discrete random variable. Let us consider two variables x and y. If they have any if there are like two discrete random variables on a sample space of a random experiment, then the probability of xy be a function which takes p of capital X, take the real value small x, and capital Y, take the real value small y. Then this function we call it as a bivariate probability function. Clear? And we can also call it as a joint probability function. Joint probability function. This probability of x comma y, we call it as a joint probability function. Now guys, what do you mean by exactly this bivariate probability function and how to solve? So let us see that now. See, for example, whenever you are calculating ages of wives, ages of husbands, otherwise you can take it as a survival of wives and survival of husbands. So you can take it. Let us consider two variables, survival of husbands and survival of wife. Right. So this way, what is the survival age of wife? What is the survival age of husband? Together the bivariate, taking x values and taking y values. Right. And x values the real values, small x1, x2, x3 and so on. xn. Similarly this one x11, x12, x13, x1n. So xn1, xn2 and so on xmn. So this way, when two variables, whenever you are considering it, where it is overlapping, that becomes a real value of both x and y. And probability of these concerns. So these are all the probability values. Let us consider. See, real values of x and y. How to write it? capital X, small x1, x2 and so on xn, capital Y, y1, y2 and so on yn, and the concerning these two probability p1, p2 and so on pn, p11, p12 and so on p1n, and p21, p22 and so on p2n. Similarly pn1, pn2 and so on pnm. So this way the bivariate table can be taken like this, along with corresponding frequencies of both x, corresponding probabilities of both x and y. So this kind of table we call it as a bivariate probability function or bivariate probability distribution here. Do you understand, guys? Now this is called as a joint, the probability of xy, we call it as a joint probability function. These are all the joint probability functions. Then what do you mean by a marginal probability function? Marginal probability function means the probability of all these. See how it can be written. Y totals where you will be considering here. X totals where you will be considering here. These are all Y totals and these are all X totals. Right? So here the marginal function, how it can be written? P1 of X. P1 of X equals to summation of probability of X comma Y for Y. Right? So these values, the columns, which we call it as a marginal function of Y totals, and then the rows we call it as a marginal function of X totals. Do you understand, guys? So this is a concept of marginal and joint function. Here we can write one more. P2 of Y equals to summation probability of X comma Y of X sums. So these two we call it as a marginal probability function of X and marginal probability function of Y. Either row or column total whenever you are considering. Suppose X values, if these totals if you are considering, these are marginal function of X. Y, these are marginal function of Y totals. Are you clear? So this is a concept of marginal probability function and bivariate probability function. So let us see the next basic definition. Independent random variables, addition theorem and multiplication theorem. The next concept is independent random variables. See, the word meaning itself says that they are independent. So they are not influencing to each other, the probability. Therefore, the probability of xy, whenever you take the bivariate function p of x comma y, the p1 of x into p2 of y, the product of these two becomes independent. Remember, when two or more variables or two random variables x and y are said to be independent, when these two x and y are said to be independent, if and only if the probability of xy, the joint probability function p of x comma y, nothing but a bivariate function, is nothing but the product of p1 of x into p2 of y. Right? So this one we call it as a independent random variable. Do you understand, guys? So next one is addition theorem. Addition theorem of random variables. So very simple. Expectation of x plus y. Expectation of x plus expectation of y. And what about multiplication theorem? Expectation of xy equals to expectation of x into expectation of y. So these proofs are not needed. Anyhow, just for the problem sake, we need to learn only these two. Expectation of x plus y equals to expectation of x plus expectation of y. Expectation of xy equals to expectation of x into expectation of y. Remember these two formula and this one. Right? These three can be useful for the useful to solve the problems. Clear? Now, see, if you see in terms of a statement, this addition theorem, if let x and y be a random variables with respect to the expectation of x and expectation of y, then the sum of these random variables becomes expectation of x plus expectation of y. So x and y are the two random variables, and with respect to the expectations e of x and e of y, and the sum of the two random variables x plus y equals to expectation of x plus expectation of y. Here look at here the multiplication and this one both are independent cases or no? Are you clear? Here probability of xy becomes probability of x into probability of y. Here expectation of xy equals to expectation of x into expectation of y. Here what we need to write? If x and y be a independent random variables, these x and y are independent random variables with respect to expectations, and the product of these two random variables, expectation of the product of two random variables is expectation of x into expectation of y. So this is multiplication theorem. Then what do you mean by a covariance? So these are all the formula what I am saying. Covariance. So what do you mean by a covariance? The covariance between x and y is, see I am writing once again the formula. Covariance of xy equals to expectation of xy minus expectation of x into expectation of y. Please remember all these formula guys. We have to apply in the problems all these formula, covariance formula. So covariance of xy equals to expectation of xy minus expectation of x into expectation of y. Now here usually if two independent random variables, if x and y are independent, if x and y are independent means what is the concept of this one, expression of xy? From the multiplication theorem you will be getting covariance of xy equals to expectation of x into expectation of y minus expectation of x into expectation of y. Cancelling this you will be getting 0. When x and y are independent, what is the formula of, what is the value of covariance? 0. Remember guys, when x and y are independent, only in case of independent the value of covariance becomes 0. And as you know the correlation coefficient, what is the formula of correlation coefficient? Covariance of xy by square root of variance of x into square root of variance of y. You understand? Now in terms of expectations, how this can be written? Gamma equals to covariance of xy formula is expectation of xy minus expectation of x into expectation of y divided by variance of x in terms of expectation of x square minus expectation of x whole square. This one expectation of y minus expectation of y whole square, expression of y square minus expression of y whole square. Clear? So please refer all these formulae. Now using all these formulae we are going to calculate the problem. Now similarly, if x and y are independent, then what is the value of covariance of xy? 0. If x and y are independent, what is the value of covariance? 0. That means correlation coefficient becomes 0 only or no? Right? So if covariance is 0, 0 by something is nothing but a 0. So correlation coefficient gamma is nothing but a 0. In what case? If x and y are independent. Are you clear? If x and y are independent, definitely the covariance becomes 0. Then if you substitute that covariance value in case of coefficient of correlation, definitely the coefficient of correlation value also becomes 0. Now, so let us see what all the formula we have seen here. One is addition theorem, multiplication theorem, covariance formula. If covariance x and y are independent, then covariance value becomes 0. And this is a formula of gamma, correlation coefficient, expectation of xy minus expectation of x into expectation of y divided by square root of variance into square root of variance of y. So this formula gamma equals to covariance of xy by root of variance of x into root of variance of y. If you simplify in terms of expectations, this is the formula. Here if x and y are independent again, numerator part becomes 0. If numerator is 0, 0 by something becomes 0. Therefore, gamma value is 0 only in case of independent random variables. Remember guys. So now, let us see the problems from the random variable concept. Look at this problem now. A die is thrown once. Getting an odd number is termed as a success. When a die is rolled, tossed, if any odd number appears, as you know that odd numbers 1, 3, 5. If any odd number appears, that will become the success it seems. Find the probability distribution of a number of successes. See here, what is the probability of getting odd number? First of all, tell me. As you all know that this is the sample space. When a die is rolled, 1, 2, 3, 4, 5, 6. Right? When a die is rolled, these are the sample points in a set. Now, since the favorable, what is the favorable case here? Getting odd number becomes a success it seems. What is the chance of getting odd numbers among these? 1, 3, 5. Getting odd numbers, right? And this is a success it seems. That is what the statement given, condition given. Odd numbers 1, 3, 5 are the success. Then probability of success. How many? Probability of success. Success is nothing but getting odd number. Right? 3 by 6. 1 by 2. Getting odd number is 1 by 2. Then what about probability of failure? That is also 3 by 6. 1 by 2, because success and failure are equiprobable. Getting odd and even numbers were equiprobable in sample space, yes, throwing a die experiment, isn't it? Now let X denotes the number of success in a throw. Write down, let X denotes the number of success in throw of a die. So let X denotes the number of success in a throw of a die. And then what are the real values? Tell me, what are the real values? Failure, take it as 0. Success, take it as 1. Then probability of X. Failure means what it is? 3 by 6. Success is also 3 by 6. As you know that the probability distribution condition, probability of any sample point, probability of anything should not be a negative. Probability of A should always be greater than or equal to 0. At the same time, the probability of sample space total is always equals to 1. These two conditions always should satisfy in any problem, remember. So probability value will never be a negative and the total probability will always be equals to 1. So this total is 1. Total probability is always 1. Therefore, this is the probability distribution. This is the probability distribution of X. So what you understood based on this question now? Any question, first we need to find out the probabilities of the real values. So real values are to be identified first. That is a step 1. So always step 1 is, for any random variable, real values should be assigned. That is step 1. Step 2, probability values should be assigned to these real values. So probability should be assigned to those real values. This is step 2. Remember, step 3 is observing these conditions. Whether probability value is a non-negativity and the total probability is 1 or no, we need to observe for any problem. Remember, so these are the 3 steps what we have to observe. First one is assigning a real values to the random variable, right? Some real values are to be associated according to the experiment, random experiment. Next, probabilities are to be assigned to those real values from the experiment. Third thing is applying these 2 conditions, whether these 2 conditions satisfy or not. In any probability distribution, these 2 conditions must satisfy. Remember guys. So this is the question now. So let us see few more questions. Look at the next question. Obtain the probability distribution of the number of heads in 3 tosses of a coin. Number of heads appearing when a coin is tossed thrice. I mean 3 times. When a coin is tossed. See, usually when a coin is tossed 3 times, what would be the sample space? Look at here, 3 times when a coin is tossed. One is 3 heads, right? And another one is 3 tails. Next, head, head, tail, head, tail, head, tail, head, head, tail, head, tail, 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 head, 3 tail. So totally 8 possible outcomes. 7 only, there is one more. Head, tail, tail. So totally 8 possible outcomes. Are you clear guys? Now what they are asking? Number of heads. Number of heads means usually maximum were 3 and then 2 and then 1 and then here 0 heads. You understand? Now what are the real values for this random experiment now? For obtaining number of heads, possibility of getting heads were 3 heads, 2 heads, right? So 3 heads. Next 2 heads, how many? Head, head, tail, head, tail, head, tail, head, head. Getting 2 heads. Next 1 head, how many? Tail, head, tail, 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 head, head, tail, tail. And then 0 tails. 1. Here 3 heads, 2 heads. Here 2 heads. Here 1 head. Here 0 heads. So clearly you observe what are the real values for this random experiment. Real values for this random experiment of 3 times a coin is tossed. That is 0, 1, 2, 3. These are the real values. So let us consider now. So this is the sample space. Let X denotes the number of heads obtained. The number of heads obtained when a coin is tossed thrice. Then the X random variable take the real values. What are the real values? X take the real values 0, 1, 2, 3. Right? So this one. These are the real values. 0 is nothing but no heads. 1 is nothing but 1 head. 2, 2 heads. 3, 3 heads. So those are all the possible ways. 3 heads. This one, 2 heads. 3 possibilities, 3 favorable cases, and 2 heads. Again 3 favorable cases, 0 heads. Only 1 favorable case, tail, tail, tail. 0 heads. You got my point? Now, these are the real values. Write down. The probability distribution of X is X equals to 0, 1, 2, 3. Then probability of this getting 0 heads. How many were there? Tail, tail, tail. So 1 by 8. Getting 0 heads. Getting 0 heads. Here 1 head, 2 head, 3 head. Clear? Next 1 head. How many are there? 1, 2, 3. So 3 by 8. Next, getting 2 heads, how many? 1, 2, 3. Getting 2 heads. That is also 3 by 8. Then getting 3 heads, how many? Only 1. 1 by 8. Look at here. The probability of any sample point becomes, the probability of the real value becomes positive. There is no negative value here. At the same time, the total probability is always equals to 1. What I said you, 3 conditions. First thing is, for any random experiment, observing the sample space and identify the real values according to the condition what it is given, right? What is to be calculated, the probability distribution. So find out the real values and then assign the probabilities to those real values from the sample space by looking at the favorable cases. Write down the probabilities and then observe the 2 conditions. Probability of any event becomes positive and the total probability is always equals to 1. Now this function, we call it as a probability function or probability distribution. You got it? So this is a problem. Now let us see in the next video few more example problems now. Hope you understand the concept random variable. Kindly refer the theoretical aspects. Definitely you will understand the concept. The random variable itself is associating a real values to the domain function x, capital X, right? Associating some real values from the random experiment, that itself we call it as a random variable. Some real values are to be assigned with respect to probabilities. Always that is a question. Random variables what we need to observe. Are you clear, guys? So this is the concept. I hope you understand. So in the next video, let us see few more example problems. Right? Hope all are doing good. Stay home, stay safe and stay healthy. Thank you. Have a nice day.